Happy Christmas, everyone. I hope you're all having a lovely day, maybe enjoying a mince pie or two. But even with all the festivities, we couldn't resist a good deep dive. And what better topic than artificial intelligence? Today we'll be unpacking what AI really is, going beyond all the hype and the, sci-fi scenarios we often see.
It's certainly a hot topic right now, and I think a lot of people are curious about AI, eager to separate fact from fiction.
Absolutely. We have a really interesting mix of sources for this deep dive. Everything from the work of early pioneers like Alan Turing to modern experts like Michael Wooldridge and Ray Kurzweil.
That's quite a range.
Yeah,
Should make for a fascinating discussion.
it really does. One of the first things that struck me was how tricky it is to actually define AI. I mean, we all kind of have this intuitive sense of what it is, but pinning down a precise definition, well, that seems to be a real challenge, even for the experts.
Yeah, Wooldridge makes that point really clear in his book, doesn't he? He talks about how even leading AI researchers don't necessarily agree on a single definition.
Right. Which probably contributes to a lot of the confusion and misconceptions surrounding AI. It's like everyone's talking about it, but they're not always talking about the same thing.
Exactly. That lack of a clear definition definitely fuels the hype and sometimes leads to unrealistic expectations about what AI can actually achieve.
It's almost like this mysterious box, everyone's projecting their hopes and fears onto it without really knowing what's inside.
That's a great way to put it. And maybe that's why understanding the history of AI is so important. If we can trace its evolution, we might have a better chance of separating genuine progress from all the overblown claims.
Okay, so let's take a quick trip down memory lane. Where do we even begin with the history of AI?
Well, a lot of people would point to Alan Turing and his groundbreaking work on, well, they were theoretical computing machines. These Turing machines, as they're called, weren't practical computers like the ones we use today, but they were really important for laying the foundation for how we think about computation and, ultimately, intelligence.
So it was more about exploring the theoretical possibilities of what machines could do.
Exactly. Turing was asking some really profound questions, like whether machines could actually think. His work really provided this framework for thinking about artificial intelligence.
That's fascinating. So what happened after Turing kind of planted that seed? Where did AI research go from there?
Well, in those early days, there was a lot of excitement about creating thinking machines, machines that could reason like humans. And the main approach was using logic and what's called symbolic AI.
So the idea was to program these systems with rules and symbols, kind of like teaching a computer to play chess, right? You give it the rules of the game and all the possible moves.
Perfect analogy. A classic example of this approach is something called the blocks world, which Wooldridge describes in his book. It's basically the simplified world where AI systems were tasked with manipulating blocks of different shapes and colors.
Sounds simple enough, but I'm guessing it wasn't quite as straightforward as it seemed.
You're right. While it seemed promising at first, the blocks world actually exposed some of the limitations of this early approach to AI. It turned out that representing and reasoning about even simple real-world situations was incredibly difficult.
So even something as basic as stacking blocks requires a lot more, well, common sense and understanding of the world than we might realize.
Absolutely. These early AI systems struggled with the complexity and ambiguity of the real world. They lacked the kind of intuitive knowledge that we humans take for granted.
And on top of that, I understand they ran into another problem, this whole issue of, what was it, NP completeness.
Yes, NP completeness, that's a really important point. It refers to a class of problems that are notoriously difficult for computers to solve. The issue is that as the complexity of the problem grows, the time it takes to find a solution can increase exponentially, even for the most powerful machines.
So it's like hitting a computational wall. The more complex the task, the harder it becomes to find a perfect solution.
Exactly. And this realization led to a period of disillusionment in AI research. It's often called the AI winter.
AI winter. Sounds a bit bleak. What exactly happened during that time?
Basically, progress in AI research slowed down significantly. Funding dried up, and there was a general feeling of pessimism about the field's ability to live up to its early promise.
So the hype bubble burst and reality set in.
You could say that. It became clear that achieving human-level intelligence in machines was far more difficult than many had anticipated.
But the story didn't end there, right? I mean, AI research eventually bounced back.
It did. And one of the things that contributed to that resurgence was this new wave of AI systems called expert systems.
Ah, yes, expert systems. Those were all the rage for a while. What was the basic idea behind them?
The goal was to create AI systems that could mimic the knowledge and decision-making of human experts in very specific domains. For example, you had expert systems designed to diagnose diseases, analyze financial data, even play games like chess.
So instead of trying to create a general purpose thinking machine, the focus shifted to narrower, more specialized tasks.
Exactly. And some of these expert systems were quite successful in their respective domains. But, they also had limitations.
Like what? What kind of limitations did they run into?
Well, for one thing, they were very rigid and inflexible. They could only perform the specific tasks they were programmed for, and they couldn't really adapt to new situations.
So it's like having a world-class chef who can only make one dish. Impressive, but not very versatile.
I like that analogy. And that lack of adaptability, coupled with the high costs of developing and maintaining these expert systems, ultimately led to their decline.
So another peak of hype, followed by a trough of disappointment. It seems like AI research has gone through these cycles, almost like waves crashing on the shore.
You're right, it definitely has. But each cycle has taught us valuable lessons and paved the way for new breakthroughs. And that brings us to another fascinating aspect of AI, its application in the world of, well, robots.
Ah, robots. Now, this is where things get really interesting. I mean, robots are tangible, right? We can see them, interact with them, and maybe even, worry about them taking over the world, like in all those sci-fi movies. But again, I think we need to balance that excitement with a bit of realism.
Absolutely. And to understand how AI is actually being used in robotics, I think we need to look at this shift toward what's called agent-based AI.
Okay, agent-based AI, what's that all about?
So think of it this way. Instead of trying to build a robot that can do everything, we focus on creating specialized systems, agents, that are really good at specific tasks. These agents can perceive their environment, make decisions based on what they perceive, and then act accordingly.
So it's about building robots that are more focused, more purpose-built, kind of like those robot vacuum cleaners that are so good at navigating around our furniture.
Exactly. And this approach has led to some pretty impressive real-world applications. Wooldridge mentions a robot called Homer, which was designed to navigate a complex environment. What's interesting about Homer is that it demonstrated this ability to reason about time and actions.
So it wasn't just blindly following instructions, it was actually thinking about its actions and what the consequences might be.
Precisely. It could understand that, for example, if it dropped off a package at a certain location, well, that package wouldn't be at its original location anymore. That might sound simple, but it showed a level of common sense reasoning that was a significant step forward. It really was. And that kind of common sense reasoning was something that earlier AI systems really struggled with. But that brings us to maybe the most significant development in AI in recent years, deep learning.
Ah, deep learning. It's a term we hear everywhere these days. But I have to admit, I'm still not entirely clear on what it actually is. Is it like, those self-aware robots in the movies, the ones that suddenly become super intelligent and decide to, take over the world?
Not quite. Hollywood does love to embellish things. Deep learning is actually a type of machine learning, which itself falls under the broader category of AI. And it's inspired by the structure and function of the human brain, particularly the way neurons connect and communicate with each other.
So instead of explicitly programming a computer with rules, we're trying to get it to learn from data, kind of like how our own brains learn.
Exactly. And a key concept in deep learning is something called supervised learning. So imagine you want to teach a computer to recognize handwritten text. With supervised learning, you'd give the computer a huge data set of handwritten characters, each one labeled with the correct text. The computer then analyzes all these examples, looking for patterns and learning to associate those patterns with specific letters or words.
So it's kind of like, showing a child flashcards with letters and words until they learn to read, but obviously on a much, much larger scale and much more complex.
That's a great analogy. And the really powerful thing about deep learning is that it can handle these incredibly complex patterns. In fact, the more data you feed it, the better it becomes at recognizing those patterns and making accurate predictions.
So in a sense, it's all about the data. The more data, the smarter the AI.
To a large extent, yes. And that's one of the reasons why companies like Google, with access to such massive amounts of data, have been so successful in developing deep learning systems.
Right. But how does this differ from those earlier approaches to AI we talked about, like symbolic AI and expert systems? I mean, it still sounds like we're giving the computer information to work with.
The key difference is in how the computer uses that information. In symbolic AI, we were trying to program in specific rules and knowledge. But with deep learning, we're essentially letting the computer figure out those rules and relationships by itself, just by analyzing mountains of data. It's a completely different approach.
And it's been incredibly effective, hasn't it? I mean, think about how AI is now being used for things like image recognition, language processing, even medical diagnosis. These were things that seemed impossible not that long ago.
Absolutely. Deep learning has really revolutionized a lot of fields. It's behind the voice assistants we use every day, the facial recognition on our phones, the personalized recommendations we see online. It really has changed the game.
It almost seems like magic sometimes. But Wooldridge mentions that some machine learning experts actually don't even consider themselves part of the quote-unquote AI field. Why is that? It seems a bit strange.
It is interesting. I think it reflects the complicated history of AI. With all its ups and downs, the hype cycles and the periods of disillusionment, some researchers in the machine learning community want to distance themselves from that.
Right, they want to be judged on the actual results of their work, not on the sometimes exaggerated claims of the past.
Exactly. They see machine learning as this more rigorous, data-driven approach that's distinct from those earlier attempts to create, well, true AI.
Okay, so deep learning is a major breakthrough, but it's not a magic bullet, right? I mean, it hasn't solved all of the challenges of AI.
Of course not. While deep learning has made remarkable progress, there are still some fundamental limitations. And that leads us to another area where AI is making a lot of headlines these days: driverless cars.
Ah, yes. Driverless cars. Everyone's talking about them. They're like the ultimate symbol of a futuristic AI-powered world. But how close are we really to having cars that can truly drive themselves, safely and reliably in any situation?
Well, that's the million-dollar question, isn't it? And the answer, like most things in AI, is, well, it's complicated. One important thing to understand is that there are different levels of autonomy when it comes to driverless cars.
Okay, levels of autonomy. So what does that mean exactly?
It's basically a scale that measures how much control the car has over the driving.
Mm.
So level 0 is no autonomy like a regular car. And then level 5 is full autonomy, meaning the car can handle everything in any situation without any human input whatsoever.
So where do most of the driverless cars we see today fall on that scale?
Most of them are somewhere between, let's say, levels 2 and 3. That means they can do some things automatically, like staying in their lane or maintaining a safe distance from other cars, but they still require a human driver to be ready to take over at any moment.
So not quite the hands-free, feet-up, fully autonomous experience we often see in the movies. And Wooldridge raises a really important point about this, about the dangers of over-relying on these systems, especially the ones that aren't actually level 5.
He does. And he uses the example of the Tesla autopilot system and how the media hype around it maybe created unrealistic expectations in some drivers and unfortunately led to some accidents.
Right, because even though Tesla calls it autopilot, it's not really autopilot in the sense that it can drive itself completely independently.
Exactly. It's a driver assistance system, not a fully autonomous system. And that distinction is really crucial. Unfortunately, the name autopilot can give drivers this false sense of security, making them think the car can handle more than it actually can.
This reminds me of what we were talking about earlier with the difficulty of defining AI and how the language we use can be misleading. It seems like similar thing is happening here with driverless cars, where the terminology can create confusion and maybe even inflate expectations.
Absolutely. And that's why it's so important to be informed and really think critically about these technologies. We need to understand the nuances, the capabilities, and maybe most importantly, the limitations of these systems.
So driverless cars, they're still a work in progress. But there's another area where AI is having a huge impact, and that's the future of work. And this is where things get a bit, well, maybe a bit unsettling.
It's definitely a topic that raises a lot of questions and some anxieties. We often hear about how AI and automation are going to eliminate jobs, but I think the concerns go much deeper than that.
Right, it's not just about job losses. It's about the potential for AI to change the very nature of work itself, potentially making it, well, more dehumanizing.
That's a key point. And Wooldridge uses a pretty striking example to illustrate this: the Amazon warehouse.
The Amazon warehouse. It's often portrayed as this kind of, futuristic vision of what work might look like in a world where AI is everywhere. Sometimes it feels like a warning, like a glimpse into a dystopian future.
It definitely sparks a lot of debate. It's a place where AI is very present, but not necessarily in the way we usually imagine, with robots replacing human workers on the assembly line.
It's more about AI systems being used to, well, to manage those human workers, isn't it? Kind of overseeing everything they do.
Exactly. And that's where the concern comes in, that this kind of AI-driven management could lead to a work environment that feels very controlled, maybe even dehumanizing.
We've all heard those stories about workers being constantly tracked, every move scrutinized by algorithms, pressure to meet these, relentless targets set by some computer system. It's a bit unsettling, to say the least.
Those are valid concerns. I think it's important to be aware of those potential downsides, even as we recognize the potential benefits of AI. The question is how to make sure these technologies are used ethically in a way that respects the dignity and well-being of workers.
It's a tough question, for sure. It makes you wonder how work is going to evolve in the coming years and how we can strike that balance between, the benefits of AI and the importance of human well-being.
Finding that balance is going to be crucial. I mean, AI isn't going away, so the challenge is to figure out how to integrate it into our lives in a way that makes our work experience better, not worse.
Right. It's a lot to think about. And speaking of thinking, we can't wrap up this deep dive without talking about one of the most mind-boggling aspects of AI, the question of consciousness.
Ah, yes, consciousness. Whether machines can truly be conscious. That's a question that has fascinated philosophers and scientists, well, probably forever.
It seems like something out of science fiction, but with AI advancing so rapidly, it feels like we might actually have to grapple with this question in a real way, maybe sooner than we think.
It's definitely a question that's moving from the realm of speculation to the realm of possibility. And Wooldridge suggests that one way to understand consciousness in machines might be to develop systems with a theory of mind.
A theory of mind? Okay, I'm intrigued. What does that mean exactly?
It refers to the ability to understand that other beings, other people, or even other machines have their own thoughts, beliefs, and intentions, that their minds are separate from our own.
So it's about creating AI that can not only think, but also understand and maybe even empathize with the thoughts and feelings of others.
Exactly. And some experts believe that developing AI with this kind of theory of mind could be an essential step toward creating machines that are truly conscious.
It's a fascinating idea and a little bit unsettling too, if I'm being honest. I mean, what would it mean for a machine to be conscious? Would it have rights? Would we treat it differently from other machines? These are huge questions.
They raise all sorts of ethical and philosophical dilemmas. And the questions that we as a society are going to have to confront as AI gets more and more sophisticated.
It can feel a bit overwhelming, but it's also, incredibly exciting to be living in a time when these questions are becoming, well, real.
It is. It's a time of huge change, and the choices we make now about how we develop and use AI are going to have a profound impact on the future.
Well, this has been quite a journey from those early theoretical ideas about AI all the way to, well, the future of work, the possibility of conscious machines, and all the complex questions in between. We've covered a lot of ground today.
We have. From Turing machines to deep learning, from driverless cars to the philosophical implications of AI, it's been a fascinating exploration.
Thank you so much for being our guide on this deep dive. You've given our listeners a lot to ponder.
It's been my pleasure. These conversations are always so stimulating.
And to our listeners, thanks for joining us on this Christmas day for this deep dive into AI. We hope it's sparked your curiosity and given you a deeper understanding of this amazing technology that's changing our world in so many ways.
And as we move into an increasingly AI-driven future, remember to stay informed, engage in these crucial conversations, and keep asking those tough questions.
Because the future of AI is, in many ways, up to us.
And if Kurzweil's prediction about the singularity is right, that future may be closer than we think.
That's something to think about, isn't it? Well, happy Christmas, everyone. Keep exploring, keep questioning, and keep learning.